and welcome to our program, Astronomy for Everyone. The topic for this month's program is the Library Telescope Program. And here to tell us all about it is Don Ficken from the Library Telescope Program. Don, welcome to the program.
Thank you.
Before we get started, could you please tell our viewers a little bit about yourself and what you do?
Yeah, so I'm a retired business executive. I got involved with astronomy a few years ago, and I've had a lot of projects, and the Library Telescope has been one of those. And I've managed to launch in St. Louis with a couple different clubs. Metro area St. Louis program. We've got almost 200 telescopes for checkout now, and 125, I think, binoculars. So it's been very, very successful.
Great. Sounds like it keeps you quite busy in your retirement.
Yes.
Please tell our viewers about the Library Telescope Program.
Be happy to. So a few years ago, actually in 2008, a guy named Mark Stobridge from the New Hampshire Astronomical Society was thinking about a common problem that people have. They really don't know, they really may not want to buy a telescope, or maybe they can't afford one. And he was thinking about the problem, and he came up with, I think, a really great solution. He says, why don't we get telescopes and place them into public libraries for checkout like a book? Wow, what a great idea. And so he worked at that a little bit. And let me just show you what this telescope actually looks like. If I could just a second bring up my PowerPoint. So you can see on the left-hand side, this is the telescope that he chose. Are you guys able to see that okay?
Yes.
Okay, so this is the telescope that he chose. And he chose it for a lot of good reasons. It's a pretty light tabletop, about 13 pounds. It's got a very sturdy base. And they realized from the beginning that this telescope, because you typically have eyepieces and things that can come out and get lost, they realized they needed to make some changes. So they basically designed some modifications to make this telescope durable and patron friendly. And they wrote those up into this little manual on the right-hand side. It's got several pages to it, and they published that on their website. And to explain kind of what they did here, on the left-hand side is the particular telescope that we purchased straight from the manufacturer, and on the right-hand side is what happens after we make those changes. It takes about 3, 4, 5 hours to make the changes per telescope. We put ropes on there, we put camera bags on there and stickers. The eyepieces don't come out anymore. There's actually a zoom lens, and it turned out that was really a great solution. It's what really made the Library Telescope Program take off was in 2011, Sky and Telescope magazine got wind of this, and they published a really nice article, and that was really something a lot of people read, and they went to the New Hampshire website, and they started downloading the instructions and just making these changes.
Interesting. Is the telescope quite easy to use then for the average person who doesn't have any previous knowledge of how to operate a telescope?
It is very easy to use. In fact, I do a lot of star parties, and what I'm amazed is how particularly the youngsters could pick up in just a matter of a few minutes of how to actually operate this. So a very typical problem with most telescopes that you buy is that they're hard to set up. There's not a very stable base. They wiggle around. Let me just show you a few people here using this, and this is again, this is really fun to see here. So this is some real life photos of some people actually using this. You can see the girl on the left-hand side. She's probably maybe 3 years old. She is literally looking through a telescope, looking at stuff off in the distance. This is obviously daytime. The middle shot is a Cub Scout that was doing this on his own. He was looking, you think it's daytime, but he's actually looking at the moon right there. I mean, it's just amazing. Literally within about 1 to 2 minutes, and I literally time this up. I'll have a line of 10 people, and I give them maybe 1 minute or 2 minutes to learn how to use it. They can operate this thing. And what you can see on the right-hand side, that's actually a photo that I took with my iPhone out of the eyepiece of that library telescope. It wasn't even a very good focus shot because I was just really just trying to demonstrate to somebody how to do it. But look what you can get. You can get great moon shots, and at the bottom you can get Saturn and Jupiter. And if you know where to look, you get double stars. It's great for young people, but it's also great for older people. And I didn't ask this little gentleman how old he is, but he's obviously been around a while. But really at every age, they find they can operate this. It's light enough you can pick it up. and you can transport this in your car. So it's been a great, very user-friendly thing as far as being able to operate.
So you talked about getting these telescopes. How do you fund the program?
I would say that the funding will vary by library. When we did our St. Louis program, we actually, as a club, astronomy club, you might say, seeded the program. We were able to give one telescope to a couple different libraries to get going. Let me pull up this slide here. We did some fundraising with different whatever groups, but what we do is we often will get donations. We have maybe a Rotary Club, or the libraries very often will raise money through selling books. I was initially very concerned about the telescope program. This is about a $300 to $400 telescope each, if you will. And I have found even the smallest libraries find ways to come up with the money. Sometimes it's a donor that has a credit card. They're happy to do this. Once they find out how successful the program is, typically the donors are lining up to help. I'm not really seeing a lot of problems with libraries finding problems with funding this program.
So the program itself is funded by the particular library?
Yeah, typically there are some. The Astronomical League does have a giveaway every year. They give away several telescopes, but most often the libraries will just find a way to buy it. It's expensive compared to some books, but quite honestly, I had one photo that of a library telescope put into operation in 2009. That thing is still going, and it's going quite well. And so most books don't last that long, particularly if particular types of books. So these things are getting they're getting a pretty good return on investment.
It sounds like it. Now, I was just wondering, with a particular library, do many of them work with a local astronomy club, do you know? Say in St. Louis, for example?
Yeah, we actually have 4 clubs in St. Louis. Those clubs, throughout the country, we've been mapping. In fact, I work with our Library Telescope Task Force. We have about, I think, 30 astronomy clubs, and even a science organization in the Netherlands that we're working with. So very often, there's bigger clubs that will do this, but it's not impossible for a small library that doesn't have an astronomy club around. They could just work with a science teacher. The telescope is pretty simple to operate, and it doesn't take much more than that.
Now, how does the program itself work, Don?
Sure. Let me pull up a slide. This one's probably one easier to actually talk from a slide. So the very typical program is something like this. You might say the rollout stage, and that's where the library will purchase, and of course they will own physically the telescopes, but they have to be upgraded. So an astronomy club or sometimes a individual with a little bit of expertise will make the necessary upgrades. There are the instructions on our website how to do that. The library has to do some checkout procedures. This is not a book, so they have to come up with a little different way to check them out. And then we really like to get the staff trained. If the staff are not comfortable with the library telescope, the patrons sense that pretty quickly, and then they're not really comfortable themselves. Once the rollout happens, then of course you have the public checkout. It begins, and what we do is we like to have public star parties. This is where we show them how to actually use the telescopes, and then we have a regular maintenance program. So it's really a fairly straightforward formula, and we've been doing this over and over again. Like there's some 800 participating locations. I would say at least 40 or 50 astronomy clubs and science groups throughout the country and the world actually doing this. So it's really not a very difficult process. This is actually one picture. Once the library rolled out one in St. Louis, this is where they were on NPR. So the libraries, they can get some really good public relations out of this. This is something that they love to talk about, becomes very popular, and that usually helps boost the programs pretty fast.
Yeah, NPR would be a great source to get the word out to people about this opportunity that's there. As you mentioned at the beginning, people who have some interest but don't know if they want to buy a telescope. Maybe they can't afford to buy a telescope.
Right.
Which one do I buy? And so this sort of lets them get their feet wet in it to see if, one, they like it, and if they want to continue.
That's right. And I think this is an interesting dilemma, because it turns out the operation of the actual telescope is the easy part. The harder part is to know how to figure out how to find something in the night sky. So we spend most of our time showing them how the sky works. It does change every night just a little bit. And once they get the handle on the basics, it gives them a great foundation to take the thing home and have fun.
Sounds like. Now, we're going to take a quick break. If you have any questions, please send us an email. And coming up next with Term of the Month is Stephen.
Thanks, Don. The term of the month is wormhole. Wormholes in space are the stuff of science fiction. Dr. Carl Sagan used one in his book and movie Contact, as have other authors. The idea is used as a way to travel stellar distances in very little time. A wormhole can be thought of as a tunnel that connects two endpoints. They can be at two different locations, but could also be at different points in time, or at both. They might even connect our universe to another if other universes exist. Marvel's Thor movies used the term Einstein-Rosen bridge. It's the same thing. Ludwig Flamm discovered the idea as a solution to Einstein's general relativity equations in 1916, only a few months after Schwarzschild published his solutions. That was only about a year after Einstein published general relativity. The idea was rediscovered by Einstein and Rosen in 1935, extending Flamm's predictions. You may think of Einstein as a theoretical physicist, but he was a real person. The related class of objects called black holes have been discovered naturally occurring, so they are real, but are wormholes real? Wormholes have not been discovered naturally in the universe, nor have they been created in the lab. Considerable thought has gone into if they can exist at all. Some scientists suggest that the math tells us that wormholes are a projection of a fourth spatial dimension in a way like a two-dimensional being could only experience part of a three-dimensional object. This would suggest that wormholes aren't real objects. Other work suggests that any wormholes that formed would be so unstable that they would collapse if a single photon attempted to cross it. Since cosmic microwave background radiation is photons, and it's everywhere, traveling in all directions, this would make any real natural wormholes very short-lived and therefore not existent. And yet, Matt Visser suggests that cosmic strings with negative mass were generated in the early universe and that many wormholes could still exist. Cosmic strings have not yet been observed. Another idea is that very small wormholes might be stable enough, though only a small amount of information could be transmitted through them. An artificial wormhole might be stabilized with some sort of negative energy. Such energy might be provided via the Casimir effect. The Casimir effect has been demonstrated, so it's real enough. What might a wormhole look like? In this image, you are looking at a simulated wormhole that connects a physics building to sand dunes, both in France. You see part of the square building with bushes and a park bench around the wormhole tunnel. Through the tunnel are the sand dunes. It's calculated using four-dimensional ray tracing in a Morris-Thorne wormhole metric. Note that gravitational effects causing redshift and blueshift have not been simulated. And that's Term of the Month, wormhole. Back to you, Don.
Thanks, Stephen. We're back. Our guest for this month's program is Don Ficken, and he is with the Library Telescope program. Now, Don, earlier you were mentioning about a star party. Can you tell our viewers who aren't familiar just what that is?
I think it's the most fun part of the Library Telescope program as far as I'm concerned. You can talk theory all you want to, but at the end of the day, people want to know what they can see. They want to know how they can actually use the telescope to find something in the night sky. Let me bring up this slide here. So there's really a couple different parts to this. I would say that most astronomers, if you talk with them about a star party, they think about going to a remotely dark spot and they're going to use their personal telescope to show you something in the sky, and that's wonderful. But the goal of this Library Telescope program, and there'll be different goals for different astronomy clubs, but I'll tell you in general what we do here in St. Louis, and actually I know several other clubs throughout the country do. It's all about hands-on training. How do you actually operate this? We want to put you in a conference room. I know it's going to be cold outside, so we'll put you inside where you can see all the parts. We're going to show you how to use that. And we will literally focus on books, which is kind of fun, by the way, to look at books upside down. And they can really zoom in. They can see a book, like the title, they can hardly even see this with their eyes. But when they put a telescope on there, this thing will go up to almost 60 power. So they can really get it close. So they get to operate that telescope, be very good at it. And then that'll take about 45 minutes with a little instructions, whatever else. And then if it's not cloudy, we'll go outside and let them actually apply their skills to the night sky. And we try to arrange our star parties to where a moon's available, because the moon is really a good target to get started. It's something that you could tell, quite honestly, as an amateur astronomer, if a little 4-year-old has the telescope on the moon, I can see it in their face because it lights up. The moon is so bright, it lights up their face. We know they can see it. And so now it's just a matter of how do they focus. So typical targets would be the moon. We try to always have a moon available. And, whenever nature cooperates, we also love to get planets, particularly Jupiter and Saturn, because you can see Saturn's rings really nicely in this telescope. And you can see the moons of Jupiter. And you can even see the cloud bands on Jupiter with this telescope. It looks like a tiny toy telescope, but it's not. It's a 4.5-inch telescope. It's really quite amazing what you can really do with this. So this is a picture of an inside person doing this inside a conference room. This is really great. And then we actually go outside. In this case, you can tell we set it up on a little piece of concrete. And that youngster is looking at the moon right there. And he's able to focus in. What's really fun about this is that I will find a 3, 4, 5, or 6-year-old, and pretty soon they're teaching their parents how to use the telescope because they picked up on it that quick. It is really a lot of fun. And of course, we typically, at least in St. Louis, and I think for a lot of clubs, we will hand out a sky map and we'll go through how does the sky really work. It changes every month, and if you're not familiar with how the sky works, it can be very confusing. You look up, let's say this month, and you look at the stars, and 6 months from now, those will not be the same stars. And so if you're trying to match constellations up to things that you thought should be up there, maybe not so. And you don't know where the planets are. And if you learn where the ecliptic is, you can learn how the planets follow a very similar path to the sun during the day, but they follow that at night. And you start getting yourself kind of like a foundation set. Our goal is when they leave that library that night, they'll be able to check out a library telescope, take it home, and actually use it successfully. That's our goal. And for the most part, I think we achieved that.
Yeah, star parties, I know the ones that we hold here in southeast Michigan, they're quite popular. People line up at any number of different scopes that are set up, and they're just amazed. Oh, I can see the rings of Saturn, or they saw the moon, the craters in the moon. They're just totally astonished. Now, you also talked about the International Library Telescope Task Force. What's involved with that?
So what happened is that we started a program. Let's step back a second. The Library Telescope program was started in New Hampshire in roughly 2009, if you will, and that started taking off throughout the country. We found out about this in 2014 in St. Louis. I launched a Library Telescope program with my colleagues, and it took off crazy. You can see behind me, this is one, we call it a build, where we took 50 telescopes and made the modifications and distributed those to 4 libraries. It was just quite a crazy success. So anyway, we were so successful in the Metro St. Louis area that we started getting other cities throughout the country contacting us on how to go about this. And so I started thinking up, well, maybe what we should do is make an international, maybe a library telescope website, which I created. And then I found a guy out of New York who is a prior treasurer of the Astronomical League, and he is also supporting, I think, about 13 telescopes in his region. And he just created a Facebook page, and I believe he's up to almost 5,000 followers right now. He's really been doing a great job of that. So we partnered up and said, let's just put together some people, let's share best practices and figure out how we grow this thing together. And so that's what we did. We started moving. Let me show you what we got right here. We have actually got a worldwide clickable map now. If I can get this thing to come up. So if you go to librarytelescope.org and you go up to the locations tab, you can pull up a worldwide map. And if you were to pick up, let's say, the United States, it would drill down, it would show you all the states in the United States. You click on, let's say, Michigan, for example, and it would bring up a list of all the known libraries in Michigan that we know about that are participating in this. So we've been slowly collecting all this grassroots work that's been done, putting it together on a list, and then posting this. We also have programs in the Netherlands right now. They just launched in, I think, 11 libraries over there, and also the United Kingdom, up in Canada. I'm sure there's many that we don't know about, but this is more like a detective thing. Let's find the libraries that have done this and get them on our map. And so we've been working this for quite a while. And so you can see that. And then, yeah, basically that's really what we've been doing. So we meet once a month. We do monthly webinars. We do share best practices, and sometimes it's talking about how to make the telescope a little more durable. Sometimes it's about they don't often have to be repaired, but how do we repair when something breaks? So we've been really working this for quite a long time to figure out the best approach for this thing.
And from the map, it looks like it's quite an involved project. I would think that in the years ahead, perhaps it'll spread to more of Europe if it's in the Netherlands at this point.
Yeah, I think it was actually the Netherlands was a pretty good start. The challenge right now is that we have a couple different telescopes. We don't always use an Orion Star Blast. It depends on, astronomers have different opinions about telescopes. I would say the Star Blast has been the most common, but the problem right now is that the shipping cost to ship from the USA to Europe is too high. So Europe, I think, rolled out a telescope called the Bressler. It's a different brand over there, but it's the same kind of concept. It's tabletop, fairly light. We've had Zummels that we've used. We've had some libraries that have used what's called burst-scopes. They're a little smaller, but that's what they could get. And so there's even some in the U.S. have done a little bit larger telescopes. But generally speaking, we have an overall process that we follow. We've also had some really great success with binoculars. The binoculars are good to see not only stars, but the birds. It's pretty good for birders. So we've had some very good success with that. And I know that I just yesterday worked with Kansas, and they rolled out another 10, I think, of those into checkout programs for libraries. So there's a lot of traction on this. I think COVID slowed us down a little bit with Europe and with some of the supply chain, but I think it's going to continue to grow.
What size are the binoculars?
That was a really big discussion we had with let me stop sharing here. That was a really big discussion we had. Astronomers want bigger, of course. They want the biggest binoculars you can get. But what happens is when you talk to birders, in other words, they want a little wider field. So we ended up with 8x42s. And the biggest issue was we want to be able to get a wide field, and get enough magnification to see things, but we don't want it too heavy. So I was really worried I did a lot of field testing with the binoculars. And what I really love to see is the Girl Scouts, pick them up and show how they can use those. And if you get much bigger than an 8x50, they can't hold them. In fact, even an 8x42, sometimes they're a little shaky with that. So an 8x42 is a pretty good set.
Great. Now, in the last couple of minutes that we have together, Don, how could a person's library get started in this program?
I think one of the best ways is to contact a local astronomy club if there's one near you, because they will be able to help you navigate the terminology that may not be you're not comfortable with. I know that when we rolled it out with the St. Louis Library, I mean, literally the director was afraid to touch the telescope. But once she realized that she could pick it up, it's only 13 pounds, and she could easily operate this, she fell in love with that. But it takes somebody to bridge that gap. But if you go to our librarytelescope.org website, and just go getting started. We give all the instructions. We have sample checkout procedures, and you can contact us. We have a lot of very experienced people who have been doing this for quite a while, and we've probably already encountered everything that you could think about to encounter, and we can really work through that. But what I do want to make clear is that we often will get someone, let's say a library, say, I love the program, can I order and you ship those next week? We want to put them into circulation in 1 month. It doesn't work that way because we have to buy the telescopes. We have to make a couple changes to where they last longer, and that'll actually make it work a long time for you. And that's really what makes them more durable and actually more patron friendly.
Fascinating, fascinating. Don, I want to thank you for taking time out of your day to tell our viewers about this exciting program. Folks, please check our website if you'd like to get some more information, and check their website as well. And coming up next is Stephen with What's Up in the Night Sky.
Thanks, Don. What's up in the night sky for January 2023? We just had the winter solstice in the northern hemisphere and the summer solstice in the southern hemisphere. Days are getting longer in the north and shorter in the south. It's a slower process near the solstices. January starts with a full moon on the 6th, third quarter on the 14th, new moon on the 21st, and first quarter is on the 28th. Then we show Mercury on the 20th of January, just before sunrise. Mercury is in Sagittarius. It has inferior conjunction on January 7th. That's where Mercury is between the Earth and the Sun, so you really can't see it. But it has maximum western elongation on the 20th, which is why we're doing this on the 20th. At end of month, Mercury rises almost an hour and a half before sunrise. Then we have Mars, the Moon, Uranus, Jupiter, Neptune, Saturn, and Venus. And this is shown on the 2nd of January, just after sunset. Mars is in Taurus and sets 2 to 4 hours before sunrise. Uranus is in Aries and sets 4 to 6 hours before sunrise. Jupiter is in Pisces and sets 6 to 4 hours after sunset. Now Jupiter has perihelion that's closest to the Sun on January 20th, and it has a size of 37 degrees. You might think, 37 minutes of arc, you might think that it would be biggest in the sky, but at the start of the month, it's 39 minutes of arc, and this larger size is due to geometry. Neptune is in Aquarius and sets 3 to 1 hour after sunset. Saturn is in Capricornus and sets 3 to 1.5 hours after sunset. Venus is in Sagittarius and goes to Aquarius over the month and sets 30 minutes to 2 hours after sunset. Pluto has superior conjunction on January 18th and therefore will not be visible. And that's what's up in the night sky for January 2023. Remember, we do not charge money for this show, but we may tax your brain.